What I'm more interested in is making power on Mars. One of the first things that Mars needs is power. And it's not just for the local generation. It's not just to make electricity to turn on the lights and, operate the AC. It's also to get fuel to come back to Earth. When the first starships land, these are Methalox starships, right? So that means they have liquid methane and liquid oxygen. What we're talking about is liquid hydrocarbons powering the rocket to get to Mars. Well, where do you get the methane from on Mars? We don't have methane infrastructure there. We don't have fracking and natural gas and like all the things that we have on Earth that get us methane on Earth. So what you can do is the same thing that we'll do here on Earth, which is we'll generate hydrocarbons from nuclear. And in some ways, the challenge is actually easier on Mars. For instance, the atmosphere is basically CO2. We don't have to worry about difficult carbon capture systems. You're basically just pulling in the atmosphere. And then the hydrogen is going to come from ice. So there's lots of ice mixed in the soil on Mars. And so we can actually process water out of the soil. We can run that water and that CO2 through the same systems that we use on Earth to generate hydrocarbons, and we can do it on Mars. Let's say we have a starship that takes off from Earth and gets to Mars, and then it needs to make its own fuel to get back. The question is, how much uranium do you need to take with you on that starship to get back from the surface of Mars to Earth, right? So you're taking off, you've got a bunch of fuel, and then you have a chunk of uranium to power our nuclear reactors to make the fuel to get you back. How much uranium do you have to take? The answer is actually a cube about this big. You need a cube of uranium about this large to generate all of the fuel to get that starship back to the surface of Earth again.
Wow.